Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Nura Afika binti Azli from Group A5. I will present about the news development of Strechable Conductive Inc. My group member is Muhammad Fatur Rahman, Muhammad Ilham, Muhammad Hanif, Abdul Rahman and Abu Fahmi. For project summary, the purpose of this study was to analyze the substitute material for the formulation of Strechable Conductive Ink SCI. It was related to the conducting polymer, which composite material comprising polymeric component and conductive component. The selected materials must be conductive, stretchable and dependable under various strain and the temperature condition. For the new SCI formulation, we propose the combination of the following material, which is for polymeric material is poly. For the metallic filler, we choose graphene. And then for the substrate material, we choose thermoplastic polyethylene.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilham Amran and I will present about background study. Okay, nowadays people want technology that are more affordable, that are less space, and can perform a variety of functions while having a top-notch performance. So the demand for SCI or stretchable connectivity is high. Since they have a high degree of flexibility and expandability, while still maintaining an externally critical performance. SCI or stretchable connecting ink is a type of functional substance that, after the ink film has been stretched or folded, it will increase the film electrical conductivity. SCI is widely utilized in electronic printing sector. Okay, next is a problem statement. Uh, we identify three problem statements. First, current SCI or traditional SCI, traditional conducting has limitation, especially in electrical conductivity, life cycle, and stretchability. Second, some material based in are very costly, such as metal basing. Third, traditional basing can oxidize under ambient pressure. That's all for me. Thank you.
Hi, my name is Muhammad Rahman bin Ami, and I will present a topic about nanocomposite. So, nanocomposite or nanotechnology can be broadly defined as the creation, processing, characterization, and utilization of materials, device, and system with dimension on the order of zero point 0.1 to 100 nanometer. Exhibit novel and significantly enhanced physical, chemical, and biological properties, function, phenomena, and process due to due to their nanoscale size. So, current interests in nanotechnology encompass nanobiotechnology, nanosystem, nanoelectronics, and nanostructured materials, of which nanocomposite are a significant part. So, based on the nanocomposite definition, we know that nanocomposite is so efficient to use in our daily life. So, here are the example of nanocomposite. First, antimicrobial activity for food packaging, aerospace industry for fuel emission, thermal stability, electrical, optical, and mechanical properties. Third, for energy store for solar cells. Fourth, wind turbine blades for one industry. And lastly, for organic pollutant removal, which is for control water pollution.
Warahmatullahi wabarakatuh. My name is Abdul Rahman bin Aziz. Today I will discuss about formulation of PDOT, PSS, graphene and PET. PDOT is stand for polytrifluoroethylene dioxyethylene. PSS is stand for polystyrene sulfonate and PET is stand for polyethylene terephthalate. PDOT PSS. PDOT PSS is the mixture of two ionomers is made up of negatively charged insulating, which is PSS, and positively charged electrically conducting, which is PDOT. SS polymer anion can stabilize conjugate polymer cation in water and some polar organic solvent. PSS is utilized to solubilize the monomer and subsequent polymer in aqueous solution while also balancing the positive charge of the dot-p-dot chain. However, the PSS chains also include sulfonic acid group with labile proton resulting in an acidic solution. Then for the graphene is a monolayer of covalently bonded carbon atom. It's a new two-dimensional material with the mechanical, electrical, and thermal properties desired for a wide range of technology. Mechanical graphene is extremely high in plane stiffness of young modulus and superior strength. In terms of electrical properties, the most highly conductive material at room temperature, the valence and conduction band of graphene overlap significantly. Furthermore, graphene is very thermally conductive. And for the last three, for PET. PET use are classified into three broad categories: fiber, bottle, and industrial usage. It may be found in synthetic fiber, beverage, food, and other liquid containers. Thermoforming application, film, plastic, and engineering resin, and is frequently combined with glass fiber. PET also provides lower gas permeability, great electrical insulation, a wide temperature range of application, and high resistance to alcohol, oil, greases, and diluents. PET's main physical and mechanical qualities include which is tensile strength with 11,500 psi, flexural modulus of elasticity 400,000 psi, and tensile elongation with 70%. That's all for me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Hanif Firasni. Today I would like to discuss about the processing technique. The first technique is the mixing process. After that, printing process, and the lastly is the curing process. The mixing process is used to combine the PEDOT, graphene, and the polyethylene terephthalate (PET) in the correct percentage based on the best formulation. The operation then proceed with a mixing process that took around 10 minutes at room temperature. A well-dissolved mixture was created by using proper stirring technique by stir in one direction at a steady speed. After that, the printing process. The printing process is complete by using the daughter plating procedure. The thickness of the exposure ink may be regulated manually with this approach to guarantee the ink is fully exposed at the fuel gap. A sharp blade was utilized to transfer the ink over the substrate at a steady pace. This procedure makes it a low-cost method for mass manufacturing flexible electronics. And lastly is the curing process. The curing process is complete in the last phase to strengthen the bonding between the particle of filler, binder, and hardener. Curing was also used to melt and harden the mixture with the assistance of a hardener to increase the adhesion between the ink and the substrate. The curing procedure ensures the graphene is adhered to its substrate, which improves its mechanical and electrical characteristics. Material characterization. For the polytrifluoroethylene polystyrene sulfonate (PSS), which is have three properties, which is electrical properties, mechanical properties, and thermal properties. For the electrical property is the testing is used the electrical conductivity testing, which is by adding the calcium and the magnesium can increase the electrical properties. After that, the mechanical properties. The mechanical testing they provide to determine the mechanical properties is the tensile test. The fracture surface and first investigate by scanning electron microscopy. SEM. After that, the thermal properties. The oxidative chemical vapor deposition is a method to determine the properties of thermal conductivity. The thermal conductivity of OCVD grown paddock films show no clear dependence on electrical conductivity.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abu Fahmi bin Sauti. I will talk about material characterization. Firstly, for graphene, in terms of electrical property, the method that used to determine the electrical property or thermal conductivity of the graphene is electrical resistance tomography or ERT. Secondly, for mechanical properties, the method that is used to determine the tensile strength of the graphene is atomic force microscopy or AFM. Finally, in terms of thermal properties, the method that we use to measure the thermal conductivity of the graphene is using microraman spectrography. For material characterization for polyethylene terephthalate or PET, firstly, in terms of electrical property, PET do not conduct electricity. However, they can be made to conduct electricity by mixing them with a material that is a good conductor. This material is called a conducting filler. Secondly, in terms of mechanical properties, for PET, tensile test is used to determine its tensile strength. Finally, in terms of thermal properties, to determine the thermal conductivity of the pad, the method that we use is transient plane source or TPS.
Hello, Assalamualaikum. My name is Nurafika binti Azli. I will present about the conclusion. For the conclusion, for the recent advance in stretchable conductive ink technology, we have three applications. First, wearable sensors. For the wearable sensors, these sensors are for tracking environmental change such as temperature, chemically aggressive vapor, strain and light and stress. Second, radio frequency identification. RFID is radio frequency identification. Is device that allow the remote reading and data storage from item equipped with such tag and has a key component in developing field of the Internet of Things. Third, flexible pressure sensor. For the flexible pressure sensor, can be easily categorized into the resistivity, capacitance, and piezoelectricity. The common sensing material are metal nanoparticle, carbon nanomaterial, and conductive polymer. For challenges and opportunities, excellent fluid characteristics are also necessary, including the right viscosity and the surface tension. For the pattern features to have a strong electrical conductivity, it is also crucial that they have good adhesive to the substrates. Due to the flexible substrate, thermal stability, post-processing by annealing must be done at a low temperature. On the other hand, the printing process need to consider high resolution and high performance printing technique.